Hello, we're going to start section 2.2 today, use a problem-solving strategy. Translating words to math. Is and other being verbs indicate equality. Addition is indicated by phrases like some, or more than, or in addition to, or there's plenty of others as well. Subtraction is indicated by phrases like difference, or less than. And again, there are other words like minus in that as well. Multiplication is indicated by phrases like product, times, or even the word of. Division is indicated by phrases like quotient, or divides, or even words like per, like miles per hour. Left angle is indicated by phrases like is less than and has fewer, whereas less than or equal to is indicated by phrases like is no more than and is at most. Greater than is indicated by phrases like is greater than and is more than, whereas greater than or equal to is indicated with phrases like is no less than and is at least. Notice the being verb included in all of the inequality phrases. Without it, such phrases as more than and less than instead indicate addition or subtraction. The being verb here is the word is. Or as is a being verb as well. Unknowns take the form of variables like X, Y, A, or B, or any letter you like. You can even use Greek letters. Example 1. Translate the following words into equations. 3 times a number plus 2 is 17. The quotient. Now, whenever I see the words sum, difference, product, or quotient, most of the time I'm going to look for the word of and the word and. That's going to tell me where the quotient starts, and then the and is going to tell me where the quotient doesn't work. Now, the word of can be substituted for words like between, and then the word and can kind of be disguised by saying like two numbers, or that's really the only one I can think of off the top of my head right now. But in general, look for of and, indicating though that there are other ways to word it. So the quotient of a number and 2 is at least. Is at least means greater than or equal to 57. The difference. So again, I'm going to look for of and, but I don't have it. Instead, I have between, and the and is kind of hidden just by using the words two numbers. Because normally we would say a number and another number, but that can be shortened to just say two numbers. So I'm going to have x minus y is less than 7. Now I'm doubling, so that means multiplying by 2, but I'm doubling the sum. So whenever you double a sum, you're going to need parentheses. And there's my of word. Oh, there is no and word though, because it uses two numbers. So x plus y is means equal the second number plus 10. And that's how you can translate words into equations. Part 2, translate and solve. Example 2, translate the following words into equations and then solve them. So we have the sum of 7 times a number and 8. So that's 7x plus 8 is 36. Now we need to solve this equation, so I'm going to subtract 8 from both sides. Get 7x equal 28. Then divide by 7. And we get x equals 4. Now for the following examples, I'm going to do it a little differently than you'll see on YouTube, but I'm going to read it first. The sum of two numbers is negative 15. One number is 9 less than the other. So I have two numbers here. So I'm going to say the first number and then the second number. Now I don't know anything about the first number, so I'm just going to call it x. But I'm told one of the numbers is 9 less than the other. So if my first number is x, that means my second number would be x minus 9. So these are my two numbers. Now I'm saying the sum of these two numbers is negative 15. So we get x plus x minus 9 is negative 15. And now we're going to solve this equation, combine like terms. Add 9 to both sides. We get 2x equals a negative 6. Divide by 2, divide by 2. And we get x equals negative 3. But notice, x was only our first number. Our second number then would be negative 3 minus 9, which is negative 12. So those are our two numbers. Part C. The sum of two numbers is negative 18. One number is 40 more than the other. So again, I'm dealing with two numbers. So I'm going to say the first number and the second number. Again, assuming I know nothing about the first number, but I know the other number is 40 more than that. So that would be x plus 40. Then the sum of these two numbers is negative 18. So we get x plus 40 is equal to negative 18. Combine like terms. Subtract 40. 2x equals negative 58. Divide by 2. X equals negative 29. So again, that would be our x value. Then our first number, and then our second number would be 40 more than that. What does that come out to be? 11, I believe. Yep. And those are our two numbers. Part D, find three consecutive integers whose sum is 96. So this time I have three numbers. So I'm going to say the first number, the second number, and the third number. So first number, I don't know anything about it, but now you need to know what the word consecutive integers means. That means one number right after the other. So what comes after x then? Well, it would be one more than x, because that would be the next number, so that's x plus 1. And one more than that would be x plus 2. One thing to keep in mind is sometimes they'll say consecutive even integers or consecutive odd integers. In those cases, you would go x plus 2 and x plus 4, because even integers are 2 apart, but so are odd integers. They're also 2 apart. Just take two consecutive odd numbers, 7 and 9. They're 2 apart. So just keep that in mind. If it has the word even or odd, you will be skipping by 2, not by 1. Now I'm told the sum of these three numbers is 96. So that would be x plus 1 plus x plus 2 is 96. Combine like terms. Subtract 3 from both sides. Divide by 3. We get x equals 31. So our first number is 31. Our second number then would be 32. And our third number would be 33. That's it for this part of the video.